Welcome everybody. Thank you for joining us. This is session 6 of our ENP study group, and it's been going very well so far. We've been getting some great feedback. We get a handful of people on the calls, and a lot of people we can see have been viewing the reportings afterwards. So that's great, and a lot of follow-up questions. So we really appreciate that. If you have any feedback for us, please let us know. Okay, so one moment here. Okay, like I said, today we're going to be talking about MLTS and location accuracy, but we're just going to start off with some introductions, and I'm going to let Holly Barkwell go ahead.
Okay. Hi, everyone. Thanks for joining us today. For those of you who don't know me, I'm Holly Barkwell. I am an emergency number professional. I'm also the NENA Canadian Regional Director, and I also own a consulting firm, Barkwell Holland Group. So when did I get my ENP? Well, a while back now. I think 2012 was when I wrote my exam, and I was terrified to write it. I ended up, there were no study groups around at the time, so I ended up studying by myself, and it took me about 1.5 years to get prepared to write it. There were other circumstances. The company that proctors the exam changed me up a couple of times, so that was part of the delay. But anyway, I wrote it and was successful. It's been an awesome experience, and it has opened a lot of doors for me, just in terms of knowledge and the ability to talk to all levels of, my background is technology, but not so much telephony. So that helped me out in that regard. And it also helped me to learn how to speak English to people so that they understand the concepts and terms. So that's what we're going to try and get around to today. I also have some background in MLTS from the Emergency Services Working Group. I chaired the TIF 73B committee, which was involved writing a report to the commission on recommendations on what to do about MLTS in the industry as it stands. And so I was on the working group, and then I was the chair of that committee as well. So just one thing to keep in mind, I know this has been reiterated a number of times, but the study guide is meant as just that. It's a guide. It's not a be-all, end-all. And so if you think you're just going to study the study guide and be able to ace the exam, that's not going to work. You need to, that is kind of a dumping ground for all of the things you should know, and then it's your responsibility to go out and find the information that you need for an individual section. So we'll try and help you a little bit with that today as we go along. Over to you, Jamie.
And for those who don't know me, my name is Jamie Toffolo. I'm our current NENA Ontario president. I also am the Quality Assurance and Training Supervisor with the Niagara Regional Police Service. I received my ENP about 5 years ago. I initially wanted to get my ENP to have a better understanding of technology, the stuff that makes our industry run, as well as just some personal and professional growth. But since then, I've really seen a lot of true value from it, especially just in trying to keep up in working groups, understanding the language and the concepts. I completely understand that studying for it is overwhelming. It was overwhelming when I did it. The study guide is very dry, can be confusing at times. There wasn't a lot of study groups also when I started, and the one that did exist was recordings that were pretty outdated. But since then, there's been a few great study groups that have popped up. And our goal with this study group is that hopefully most of the participants are familiar with each other, they're familiar with the subject matter experts that are presenting, and we're really hoping that we can present this in a personalized way that makes you feel comfortable reaching out if you have any questions. You can reach out to any of the presenters or anybody on the NENA executive, again, just for tips, helping you flush out concepts, whatever it is that you need. So just bear with me. We've got a few more people in the waiting room. I think it's going to jump the presentation over again. And if you see a hand up, please tell me, because again, I can't see anything bad right now. Okay, so just to get started, these are our learning objectives. We're here to understand the MLTS environments and challenges. We're going to learn a little bit about Kerry's Law and the Ray-Baum Act. We're going to review MLTS configurations, and then we're going to finish with a bit of a knowledge check. If you're following along in your ENP study guide, these are the sections that we're going to be covering. We just want to stress and reiterate, don't panic. There's a lot of acronyms. There's a lot of terminology that we're going to be reviewing. If you have questions, ask us as we go along. But also remember that the NENA glossary is your best friend. You can bring it up during the session. You can bring it up during all the sessions. You can bring it up during working groups. It's really going to, when we say it's your best friend, it is going to come through for you. Okay, just to start, what is MLTS? MLTS stands for the Multi-Line Telephone Systems. It's formerly known as the PBX. It creates unique 911 location challenges because they often connect multiple phones, buildings, or campuses under a single system or a single server, which breaks down the assumption that we have that a phone number equals a unique physical address. And that presents a whole bunch of different challenges that we're going to get into, but that's not necessarily the case. A single phone number does not necessarily equal a single address. So the MLTS systems are a common solution to commercial communications deployment strategies, and significant concerns exist in our public safety community with how these systems are deployed. So service providers or resellers have multiple options on how they can configure these systems. And then there's different types of consequences that are as a result of that, which include directly affecting emergency response by denying or delaying connection to the 911 service, delaying response due to incorrect routing of a call to the wrong PSAM. It could result in incorrect location data, which can affect routing of calls and the quality of location data available to the 911 call taker, or lack of or incorrect location information being available based on mechanisms used to connect the call to the 911 network. In Canada, the Commission is concerned with ensuring callers can dial 911 from behind an MLTS switch or service without dialing a prefix or access code. So that's that 9 that you often have to dial out, like to get out of a building when you're in like a hotel or whatnot. The Commission is also concerned with controlling means for placing untraceable 911 calls to primary PSAPs, which could result in harassing, annoying, obscene, like threatening, or those false calls to 911. Commission is also concerned with reducing the number of 911 calls where the ANI, the automatic number identification, is invalid, and improving the availability and accuracy of location information. So as you can see on the slide, the caution is the MLTS is really designed for business efficiency. It's not designed for emergency location accuracy. So we're going to talk about those challenges. Go ahead, Holly.
Okay. So we're going to talk about MLTS and interconnection with E911. So the study guide explains MLTS 911 interconnection. So we're going to go through a little bit of this in detail. So there are really 3 types of main configurations for MLTS systems. So you have a single building, which is a single location. You have multiple buildings with a single address, or you have multiple buildings with multiple locations. And each of these, so if you, for the first case, for a single building, single location, if you envision perhaps a hospital or a school. For multiple buildings, you can picture either a college campus or some kind of a business with multiple buildings on the same property. In the third example, you can think of a multinational corporation where you have a head office somewhere and then you have branch offices in different cities and sometimes in different countries. So those are the main 3 types of environments. Modern MLTSs may use distributed architecture where a central system serves the remote sites, sometimes across jurisdictions. So when you start moving into different provinces and different countries, that adds a level of complexity. So in each of these cases, you may have 911 trunks located at the core MLTS or the core server, or in the cloud, which further complicates the accurate location delivery and routing for emergency calls. Next slide, please. Okay, so we're going to talk about them each individually. So first, you have a single building, a single location. So depending on how the system is configured, and the difference here is when you have lines that come into 911, the telco configures those for you. And in some large institutions, the telco configures those. But MLTS systems, by and large, are sold by third-party or small vendors, and then they are configured by the vendor, not by the telco. Sometimes major carriers or smaller resellers will program them according to what we need, but most often not. So the systems, when you call 911, it automatically receives data. And generally, what is configured with these systems is the main address. So you get a main building address, but you don't get a floor suite, which means that you don't get the caller's exact locations. The other complication with these configurations is that all phones within the building are configured with one main number, which is probably the main phone number to get into the business. So that doesn't give you any clue where the caller is actually calling from, because the caller could be on the second floor, the 10th floor, the east wing, the west wing. They could be in a secure area or a public area. So 911 has no knowledge of what's going on at the particular location, and that means they need somebody to interpret that, which slows down the response because responders have to wait for somebody to arrive on scene to direct them. So if you think of college campuses, hospitals, schools, courthouses, anything like that. Okay, next slide. So the next one is you could have multiple buildings on a single location, and the easiest one to envision there is a university or college campus. So in those cases, you would have one civic address with multiple buildings and one shared system. So you could have hundreds or thousands of phones, depending on the size, and all the calls, any 911 call coming from any of those buildings or any offices in those buildings appear to come from the same address, because it's configured potentially with the same address and the same phone number. So we don't have the benefit for 911 of which building, which floor, or which room that the call is coming from. So although technically the address may be correct, it may not be the correct building, may not be the correct entrance. It could be, again, a secure or restricted area. In each of these instances, again, you have to, the calls in some cases go to the gatehouse, or they are routed through the gatehouse before they go to 911. So we are eliminating or trying to eliminate that scenario so that the calls go directly to 911. They can be routed simultaneously to a gatehouse or some other area for notification, but they cannot impede reaching 911 directly. Next slide. Same thing with multiple buildings and multiple locations. Generally, the way these are configured is you will have a main server located at head office or wherever that might be. That has a main phone number and that has an address. But now if you have something, the head office is located in Toronto, Ontario, then you have a branch office in Texas somewhere. So it obviously does not have the Toronto address nor the Toronto phone number. If a caller picks up the phone within the business to call 911, it gets routed through the trunks over to the Toronto office, and the call ends up at 911 in Toronto, which is obviously the wrong PSAP to begin with, but also does not contain the correct address or calling information. So that in turn delays the call because now the PSAP has to go hunting to find out interrogating the caller to find out where the call came from, what city they're in, location, etc. Oops. Okay, so here is kind of a summary of what we have. So in case number 1, which is the single building, single location, at least the call goes to the correct PSAP. So the responders know where the building is, but they don't know where the caller is. So they have to do either additional querying or they have to go to the building to receive assistance on finding the caller. In the second scenario, with multiple buildings and single locations, the responders may arrive at the wrong building, the wrong entrance, the wrong road access for that matter, depending on where the best access for that building is. So they may get there, they may not get to the right building, they definitely won't get to the person. And then in the third location, the call may not even get to the correct PSAP if the system is not configured correctly. The call may be routed to a different city, so you get to a different PSAP, or it arrives at the right PSAP but with the wrong address and phone number that contains no information. Next slide. Okay, so the challenges, we've covered these. Inaccurate or generic location information. You can have one number that services many phones, which is less than helpful. You also have distributed and cloud architectures, which makes it a little bit difficult to hunt down trunks if those calls are even doable anymore. The other complication is that the devices in these buildings are constantly moving. So people move offices, they take their phone with them. They quit, they get reassigned. So the addresses change, or the actual IP addresses of the devices change. So we lose visibility within the system to find those devices. Resulting in delayed emergency response, obviously. So one, the PSAP has to do more querying to figure out where the person is, which again, in turn, delays the response to the actual building or to find the people. It also probably, pardon me, it's getting late in the evening, obviously. It creates some compliance and liability risks because you can't find people. So keeping in mind that MLTS systems were originally designed for businesses, not for calling 911, and certainly not for location accuracy. So when these systems were originally installed, there was little consistency in the deployment. So because they are based on computer systems, they have the capability to be configured with the proper information to reach 911. But in most cases, either the reseller or the VAR, the value-added reseller that is installing them, they either don't care or they don't have the manpower to correctly configure these systems. So that results in inaccurate or no ANI-ALI information. And in some cases, a prefix still to get out. So it depends on the age of the system. It depends on how bad the configuration really is. So even though the call originates from a main number, we don't necessarily know what floor, suite, building, or city the call is actually coming from. So as we covered already, a single MLTS system may cover one building, it may cover multiple buildings, it may cover multiple cities, it may be a cloud-based system at all. There may in fact be no hardware on site other than a small server to do the call routing within the building. So this totally breaks our traditional assumption of the original implementation of E911, which is one phone number equals one incident or one physical address. So that doesn't exist anymore. Next slide. Okay, so these are the challenges for the PSAP. It affects the PSAP's ability to determine the exact location of an emergency to provide timely assistance. And number two, it creates additional workflows for 911 communicators to be able to fill in the gaps in information, because you obviously have to query the caller multiple times or for an extended period of time because, God forbid, it's a visitor to the area. The caller may, in fact, have no idea where they are. And outside, at least you can ask for landmarks and visual cues. If they're in an office building or a hotel somewhere, they may not be able to give you any useful information at all. So just a little tidbit of extra information. In July of 2021, the ESWIG, so the TIS 73B committee, submitted a report to the RTC outlining these challenges for Canada. And in September of 2022, the Commission issued a decision 2022-265, which outlined these issues and what we should do about it. But it also included an appendix with best practices for provisioners of MLTS systems. We are still trying to get that information out into the wild, but it is a daunting task. So we approached associations and gave them the information and asked them to give it out to their clients, I guess, if you will. So we'll see what happens. We are still awaiting a new decision from the Commission anytime now, is what we are told. So I'm waiting with bated breath to see what new information may come or direction may come from them. Okay, so you will see the term in your study guide, ECS or Enterprise Communication System. It is essentially the same thing as an MLTS, and you'll also see a PBX, which stands for a Private Branch Exchange, which is an old term meaning the same thing. So the three of them are pretty much equivalent. Some may be smaller, some may be larger, but a term does not define anymore what type of configuration. They're all just MLTS systems. What is important to remember is that small deployments typically don't assign unique phone numbers to individual devices. Instead, they tend to use the main phone number for outbound and emergency calls, unless the provisioning company is educated in 911 service and how it works, or uses a carrier-provided PS Alley tool, which we'll talk about in a few minutes, to properly configure the system. Okay, next one. Okay, so we'll talk a little bit about Kerry's Law and the Ray Bombs Act. So Kerry's Law started back in 2013. Carrie Hunt was staying in a hotel in Texas with her daughter. She was violently attacked in her hotel room by her ex-husband, and her 9-year-old daughter tried to call 911 several times, but was unable to reach emergency services because the hotel required that you dial 9 as a prefix to reach an outside line. So she was dialing 911, so she was getting the outside line, but the 911, there was no connection with the line. So it was a critical failure in the network. So the phone system blocked the call. So no warning, no error tone on the call. So no fast busy or anything. So therefore no help received. The outcome of that was eventually a call was made, and by the time help arrived, it was too late. Carrie Hunt had died. Her daughter had done absolutely everything a reasonable person could be expected to do, especially a child, to get emergency help, but it never showed up, unfortunately. So the result. So Carrie's father, Hank, advocated for change, and he still does today. He's a huge advocate for 911, and NENA has partnered up with him on numerous occasions. So on February 16, 2018, Carrie's Law came into effect, requiring that no prefix was required to dial 911. So they had to stop. Any systems deployed after that date could implement no system to prevent calls to 911. So the call could not be delayed. It could not be rerouted. It must go directly to 911. And someone on site must be notified that a call was placed to 911. So either to security, to the front desk, whoever, and notify them that help was on the way. It actually wasn't, it was only in February 16 of 2020 that the FCC mandated that companies had to comply with the order. So it took a couple of years in order for it to come into being. Okay. So the other important thing was the notification needed to make sure that there was a callback number delivered with the call. Sorry. So following on Kerry's Law, Ray Baum's Act, and there are, a number of things people say, what does Ray Baum stand for? Well, it actually stands for, where did we put it? There is an acronym. I'll get it for you in a moment. But people think it's about Ray Baum, a senator. It was not. It was actually reallocating bandwidth of some sort, and I will get to that in a second. Anyway, Ray Baum's Act followed on to Kerry's Law in recognizing that this is all well and good. We can get the call to 911, but if we don't have a dispatchable location, we can't go anywhere. So Kerry's Law addressed getting the call to 911, and Ray Baum's Act addresses how the responders find you. So it included the concept, or it introduced the concept of dispatchable location, which includes street address and additional information such as room, floor, etc. They needed whatever was needed to adequately identify the caller's location. So again, the FCC implementation required that companies follow the direction either in January of 2021 or January of 2022, depending on the nature of the system that was installed. Some were analog, some were VoIP, so that created some issues, whether the device was fixed or not fixed, pardon me. Okay, I think we've covered that, so back to you, Jamie.
Sorry, just gotta restart this. Okay, so now we're gonna get into different MLTS configurations. Each, again, has their own challenges, similar to when we were talking about the MLTS environments. The first one we're going to talk about is this MLTS using the main telephone number. And then we'll follow along with your guidebook, and we'll talk about MLTS using PS, ANE, and URL, host and remote configurations, and then we'll end by talking about VoIP and EIP MLTS configurations. So again, just starting using the main telephone number. In many MLTS environments, all 911 calls use the system's main telephone number as the ANE, so as the phone number, rather than the unique number assigned to each individual phone. So if you think of a large office building that uses an MLTS, you can think of it as like the company's main phone number. If it's something like 905-555-1000, but then each individual desk has their own extensions, those are extensions that are not unique phone numbers. So when an employee from an extension dials 911, the MLTS sends the call to the PSAP, but the phone number that's displayed at the PSAP is the main phone number, not the extension, not the floor, not the room. It's not the caller's exact location. And this is just a picture of that call flow here. So here we have an example of this. So the, again, the ECS, or the, MLTS, that's again just a smaller version of the MLTS, places a 911 call, and it travels through the switch to the PSAP. When the phone number, that ANE, gets queried, queries the DBMS, that database management system, it returns the alley or the location. So again, the problem is that when the alley information or the location information is returned, it represents the address of the MLTS, so that main building address, not the actual location of the calling phone, the phone that's dialing 911. So if you think back to the different MLTS environments, that workstation or that phone or office, wherever that call is being placed, could be on a different floor, could be in a different wing or building, or it could be at a remote site. And as a result, so the caller's true location may be significantly different from what appears in the alley record, and that in turn creates the risk for delayed or misdirected emergency response. Back to you, Holly.
Sorry, I'm chatting away on mute. Okay. So now we get a little bit more complicated because, why wouldn't we, as we get more specific. So we're going to cover the next two sections like kind of together. I'm not sure why the study guide put them in the same bucket, but anyway. Okay, so a couple of terms. So PS Alley, what does that actually mean? So public safety automatic location information. So it is, private switch automatic location information. It is a tool that allows an MLTS system to send specific location information, not just a main billing address when a call is made, but with more granular information depending on how much information they want to populate the system with. So instead of every call appearing from the same phone number, PS Alley provides vendors the ability to provision more information such as direct inward dial numbers or DIDs to find the caller and to locate them within a large building. So each phone or area within the premises is assigned an ERL or an ERL. And I'm laughing because I was reading somebody's bumper sticker today that says ERLs in the trunk, but from a Dixie Chicks song. Anyway, so each phone number area is assigned an emergency response location. So for an example, it would be building A, floor 3 in the West Wing. So each ERL is linked to an emergency location identification number or an ELIN. The ELIN acts like an ANI in that it's a unique phone number. So when the system goes to query, it will come back with the specific emergency response location information or address for a 911 call. So how this all works. So the MLTS system sends the ELIN as the ANI, and then the PSAP uses that ANI to query the alley database for the location record. So it should come up with the main street address plus a sublocation within that property. Oh, sorry, go back for a second, Jamie. I forgot to. So the result is that every call obviously comes from a unique phone number, but the note I want you all to take away is that it's the MLTS owner or the provisioner that is responsible for creating and maintaining these location records. They can do it themselves, or they can contract, or they can pay money to Bell or TELUS to do it for them. There is a tool there to do it. So just so you are aware of such things, if these calls come in, you can certainly remind customers that they should talk to their vendor and recommend that they take appropriate action. Okay, next slide. So how does it work? So location records are assigned to phones or groups of phones, depending on how they're located, and that becomes an ERL. And then a location-specific identifier is sent to 911 when a call is placed. So that's the ELIN. So think of it as the emergency response location is linked to the specific location within a building, and that is linked to emergency location identification number or the ELIN, and the ELIN acts like the phone number. So it's the ANI. Makes perfect sense, right? Like mud. Okay. Next slide. Okay, so when someone dials 911, the MLTS, so the call goes out, the MLTS sends the ELIN as the ANI. The call or the call handling system uses that ANI to query the alley database, which returns a specific ERL with more information than just the main address. So it would be the main address plus whatever other information has been provisioned in that system. And as you can see, our diagram gets a little bit more complicated. So the call goes in, the call path goes through, delivers the ANI to the PSAP, or in this case, our ERL, our ELIN, and then down below the data follows. So the ELIN goes in, dips the alley database, which then gets sent back to the PSAP. So the call path is completed. So again, the problem is this is all well and good if the owner or the provisioner of the MLTS system configures it properly and keeps it up to date, because often they get provisioned and then people walk away and then the data gets stale like everything else that we deal with. So if nobody's updating the URLs and the ELINs when they call 911, when the dip goes into the alley database, the location information, we hope, cross our fingers, will be correct, but may or may not, depending on where the location, especially if that device is moved to a different location. Okay, back to you, Jamie.
Okay. So we're just going to continue to build on those configurations. The next one is host and remote setups. So this setup is commonly used by large multi-regional organizations. And in this configuration, you have a main host, like the main or host MLTS that serves as sort of a central system. And then you have one or more remote MLTSs that are connected to it. And those remote MLTs may be located in different jurisdictions. So for example, if you think of a hospital that has remote sites and clinics, if someone dials 911 from an off-site clinic, the call goes through the main hospital address, if that's where the host MLTS is located, and the ANI, the phone number from that main host MLTS is what gets presented to the PSAP as the phone number. A lot of retail stores do this. Like we'll get calls in the PSAP from chains, like a small dollar store that gets connected, and the address actually gets routed through their main site, right? So it's really important that there is a proper 911 configuration, including those ELINs that Holly was just talking about, so that the responders go to the right address. And here's where our DIDs come in. These configurations often use those DIDs, which are the direct inward dial numbers. So those are those numbers where they can be reached publicly from outside of the organization. It's like a telephone number, and it bypasses the main switchboard or some sort of auto attendant, and it connects directly to a specific extension or device on the MLTS. So for example, us as the PSAP, we have a public phone number for people to call the police, and they would go through our switchboard and the automatic voice recognition system and select whatever it is for to get through to dispatch. But EMS can call us directly through our DID line. So that's the telephone number that's assigned directly to our unit. They don't have to go through that. And I'm sure many of you can think about your own PSAP and the DID lines that you have likely also with your the PSAPs that you're connected with. In many MLTS and PS Alley configurations, the DID is then sent as the ANI when a 911 call is placed, and that DID is what is linked in the Alley database to the specific URL. Okay, so basically the location is now being associated to that DID number, and that is what allows 911 then to receive location-specific information instead of just a generic main address. Okay, so I hope that makes sense. Also, these host or remote MLTS environments have jurisdictional considerations. So again, if you think back to when we were talking about different environments, these remote locations could be located in different provinces or around the world really, but they could link up to a different PSAP. So because the host MLTS and remote MLTSs may be in different jurisdictions, each MLTS location must have its own 911 trunks. That's so these trunks can connect to the appropriate E911 selective router for that jurisdiction, which then allows the emergency calls to be routed to the correct PSAP. So that part's really important. Once that 911 call enters the network, the call processing occurs in the same way as it does at other MLTS PS ANI calls. The selective routing, transfers, and fail-safe functions all apply. And here's our updated call flow. So again, when a 911 call is placed, the host MLTS feeds the URL and ELIN information to the DBMS. And then that sends the location, the ELIN information, the specific location information to the ALI database. So it's ready when the PSAP queries it. So when the 911 call is made and it goes to the PSAP, it's going to query the information that is fed. So it's the same problem as we had before. The MLTS owner is responsible for maintaining and updating location records. And if they don't do that, then the incorrect location information is going to be presented to us on the other end as the call taker.
Okay, so now, because it wasn't complicated enough before, let's add some more concepts to this. So, VoIP and IP MLTS systems. So, copper lines are replaced by VoIP. We all know how that worked across Canada. It's like everybody with a device called 911, and it ended up at Northern 911 or a PSAP in Quebec or somewhere else that took default routed calls, because that's the way VoIP calls are routed. Anyway, different technology, but similar location challenges because they get default routed. The same thing is happening in G, because businesses or whoever are using VoIP systems need to have a copper line in order to route the calls to 911 properly. Otherwise, they will continue to be default routed, which most of them are today. So, and we call that a VoIP positioning center to route the 911 calls. So they can treat business MLTS the same as it does a VoIP provider, depending on how they're configured, if they are on IP and they are not routing 911 calls over a copper line. So a 1SL or a plain old POTS phone line is required in order to make calls from these systems go route properly to 911. Okay. Okay, so when a VoIP user dials 911, the call is sent from the MLTS to the third, or to the, what do we call that? The positioning center, which determines the caller location, we hope, assigns a pseudo ANI, which is, if you've done your homework, it's like we assign it a hard address. Think of it like a radio tower. Radio towers don't really have addresses, but in order to make phase one location work, cell towers were all assigned addresses so that roaming people could be found. Similar concept. So from there, the call is routed to the appropriate PSAP, and the PSAP uses the pseudo ANI to retrieve the location information from the VPC. So the VPC in this case acts as the location authority and ensures that the call is reaching the correct jurisdiction with a dispatchable location. So there are many issues with this configuration. Sorry, go back to the drawing for a sec.
Oh, here, okay.
Thanks, Jamie. Sorry. There are many issues with this configuration. However, there is the call flow. So the enterprise VoIP MLTS makes the call, it goes to a VoIP positioning center, and then it gets to the PSAP. So in this case, you can think of the VoIP positioning center as the third party call center, which is the default routing process for VoIP calls today. Okay, and I think that is everything we have, but the last part.
Yes, that's a lot of information to digest, a lot of acronyms, a lot of configurations and environments. We just did a little bit of a knowledge check at the end, just to kind of summarize some of the key concepts and to help you better understand the information we call it for the exam. I know Holly just mentioned the pseudo ANI. I just wanted to say that we glossed over it because it gets covered in the next session. So don't worry about understanding that concept too much right now. But again, just for your information, some takeaways for you to help understand everything to do with MLTS. I came across this mnemonic device just to break it down for you, but multiple phones, limited location, shared numbers, and moving targets, sort of a way to understand what MLTS is. Remember, EARL is where the emergency is. ELIN is the number that tells 911 where to send help. And the EARLs are what divides large MLTS sites into those dispatchable response areas so that we know where to send help. The ELIN acts as the ANI to deliver EARL specific location information. So it acts as the phone number to deliver the location of the person calling 911. The PS alley is what enables accurate location when preserving normal E911 call handling. And the PS alley is only as good as the data behind it. And that's one of the main problems that we emphasize throughout this presentation. With MLTS, ANI and alley often identify the system location, not the caller's true location. Holly talked about Carey's Law, and that kind of looks at, can you reach 911? And it took away the
Prefix.
The prefix 9. Thank you. If you're dialing out from an organization. And then Ray Baum's Act answers, can responders find you? So they're linked. The Ray Baum Act follows Carey's Law, but they're two different things. Looking at the DID, that's the phone numbers, that direct phone number that can act as an ANI for 911. VPC, the Voice Positioning Center, treats enterprise MLT and VSPs the same. And the CRT decision that Holly had referenced earlier, 2022-265, proposal to manage multi-line telephone systems in the Canadian Enhanced 911 or Next Generation 911 environment. Okay, those are some takeaways for you. But again, this entire presentation, the recording will be available in the next few days. I believe Kate's going to send it out to everybody. So that's it for our presentation. Does anybody have any questions or anything else I'd like to go over? And okay, we see some hands. I don't know if this is the order.
Cynthia is showing as number 1.
Who's that? Sorry, Cynthia?
Cynthia Mamer. Yeah.
Okay, Cynthia, go ahead.
Yeah, hi. So we covered Carey's Law and Ray Baum's Act. Those are acts that are American or US based, right? Does Canada have anything similar or have adopted something like that? Yeah, is there anything equivalent?
We do not, but Canada follows what the US does fairly closely. So, and the thinking is that most of the equipment that we use in Canada is built in the US or for use in the US. So by default, because manufacturers have to follow or have to abide by Carey's Law and Ray Baum's Act requirements for provisioning systems, that we will get the benefit of those here. Now, having said that, we are introducing, I guess, more robust guardrails for MLTS systems, and that's what we're waiting for from the Commission right now.
Okay, perfect. Thanks very much, Holly. I also had a second question, and I'll leave it at that so other people can ask questions. One of your last diagrams, I did notice it had the acronym ESQK. I think that's Emergency Service Query Key or something. Will that be discussed or clarified in another session?
Yes, that comes up again.
Awesome. Thanks, Jamie.
Okay, nice. There were a couple other hands up, but I can't see who they were now.
I have Jason Fournier. Jason, go ahead.
Yes. So, yeah, I'm just looking at the diagram in the manual regarding 2.10.4 host MLTS with remote MLTSs. So this is where we have a host MLTS, one or many remote MLTSs. Now, you mentioned that the remotes have their own trunks into the PSAPs, into the 911 TAMs and selective routers. That makes sense to me. So Toronto will route to Toronto PSAPs, Calgary will route to Calgary PSAPs, but the diagram shows that the ELIN's updates go to one set of NELA databases. And I didn't know if those databases are Canada-wide or if it's up to the remote MLTS to also update the Calgary and NELA databases.
So very good question. And that would be up to ideally the PS Alley tool to make sure that those updates are done in all the correct places. But that is a very good question. I don't know the answer to that off the top of my head, but I will find out for you.
Thank you.
Because ideally they would each have their own trunk to 911, but because we say it is so does not make it so, unfortunately.
Yeah, it's the diagram in the book, figure 216, has the two trunks into the separate tandem routers, but then only one NELA database. That it doesn't quite compute in my head if that would make sense, that Toronto and Calgary would have the ELIN updates just from one set. It wasn't computing.
Yeah, I'm wondering if it's almost done like that for the simplicity of the diagram.
Yeah.
Maybe.
If it's provisioned properly, then it should have a separate trunk to 911 from whatever service provider territory it's operating in, which means that it would in fact require a separate alley record or any alley record in each operating zone. I'm going to have to check with Bell and yeah, I'm going to have to check with Bell and Telus to see if that's actually the case. That's the way it should be, but again, should and are don't necessarily jive.
Right.
I think to that point, and a lot of the emphasis on the problems that we went through today, like if they're not updated, it's not going to function that way.
Yeah.
Let's go. Any other questions? A lot to digest.
Either we did our job really well or nobody picked up anything.
I think it's a pretty a heavy topic
Yeah.
in the study guide, but we can leave it at that. You know how to reach out to us. It was at the end of the presentation. Any one of us on the executive at NENA. Holly's the expert, one of our Canadian experts on the MLTS environments, and always available to answer any questions. So reach out if you have any questions about this session, any of the sessions, and otherwise we will see you next week. All right, good night, everyone.
Take care, everyone. Can you disconnect, Kim? Oh, okay.